Hello everybody, this is Holden. I want to welcome you all to the 6R help session. Today I'm going to be going over some stuff you need to know for the 6th homework. We're going to get started with calculating expected value. So let's say we're given the set of values 0, 1, and 2. And the probabilities of it being each of these values are 40%, 20%, and 0.4%. These values correspond to the number directly above. So there's a 40% chance of the value being 0, a 20% chance of the value being 1, and a 40% chance of the value being 2. If we wanted to find the expected value, what we would do is multiply 0.4 by 0, 0.2 by 1, and 0.4 by 2. We're just multiplying the value by the probability of it being that value. And we would get 1. However, there's a much easier way to do this. It's using vectors. Let's review vectors really quickly. A vector is when you set a value of something equal, or a set of values equal to a number or name, or you could even do this with model, as I showed you with linear models. But for the purposes of this example, let's just set it to numbers. We've created a vector for A and a vector for B. As you see, we can sum these vectors, we can multiply the vectors, we can divide the vectors. Because these are treated as numbers, you can see this in the global environment. So an easier way to do the problem I started off with today is creating vectors. Here's a vector for values. Our values are 0, 1, and 2. Our probabilities of the values are 0.4, 0.2, 0.4. Make sure they are in the right order, as in 40% chance of 0, 20% chance of 1, and 40% chance of 2. If they're not in the right order, R will not compute the expected value correctly. To get the expected value, sum values times probabilities, and as we can see, the expected value is 1. If we come back to the first way I showed you, it is 1 as well, but it is a lot more efficient to do it using vectors. The only reason I showed you the calculation without vectors is because I think it's very important to understand what's going on at a conceptual level. You should definitely utilize R to become more efficient, but the conceptual understanding is also important. Next, let's go into how we would get the standard deviation with the same numbers. So I'm going to erase this, and this is calculation for expected value, or the mean. Let's name expected for the expected value we calculated, because we're going to need to use more vectors for the standard deviation. Again, you could do this by hand, but with vectors is a much easier way. So I'm just going to be going over it with vectors, and you can follow along conceptually by what I'm going to name the vectors. So as I showed earlier, expected value is sum values times probabilities. Next, let's get the squared deviation. It's your values minus expected squared. You might notice that this mirrors when you're calculating standard deviation by hand. You take your value minus the mean and then you square it. To get the variance, you sum the squared deviation times the probabilities. And to get the standard deviation, which is what we've been looking for the whole time, is the square root of variance. And then just type standard deviation to print it. And the standard deviation is 0.894 in this instance. As you may recall, standard deviation is the square root of variance. If we print the variance, we get 0.8. Square root of 0.8 is 0.894. You could do it that way, but in my opinion, it's easier to just do it this way so you don't get confused and think this is your standard deviation when it's your variance. Now let's do the same calculation but in a different format. Let's say we want to get the expected value of x plus y, and we also want to get the standard deviation of x plus y or x minus y, because they will be the same. Let's also give the detail that the mean value of x is 5, or let's just say it's 20. Let's say the mean of y is 10. To get the expected value of ex plus y, you just add the values. So the expected value is 30. To get the to get the standard deviation, it's a bit more complicated. Square root of, let's say standard deviation of x is 12. Standard deviation of y is 3. To get the standard deviation of x plus y, we take the square root of 12 squared plus 3 squared. This is our standard deviation. I'll write a general formula here. The square root STX squared plus STY squared. This is a general formula if you would like to write this down, or you can just include an example. Generic formula for this is expected value x plus y is mean dot x plus mean dot y. I would like to leave you with an example or a word problem in which you would use this information. I'll set it up first. 100 marbles, 80 blue marbles, the rest are not blue. We replace any marble we draw. We're drawing 15 marbles. This means we know 0.8 chance of blue marble. That's just because it is 80 over 100. That's a 0.8% chance. Now let's calculate the expected value, the mean, and the standard deviation. Mean is n times p. N is 15 because we're drawing 15 marbles. P is the probability of a blue marble. So 12. 12 is the mean in this situation. The standard deviation is square root n times p times q. So it's square root 15. We're drawing 15 marbles. P, probability of a blue, times q, probability of not a blue, which we can get 1 minus p equals q. Our standard deviation is this number right here. That should cover everything you need to know for homework 6. You might need to brush up on your probability skills, but this is how you create vectors in R. Again, I would like to emphasize that you should understand this from a conceptual level before just memorizing square root NPQ or any other vectors or formulas. Thank you for watching.